Now let's look at the PV function, that is the future value function. The description of this function is, this function calculates the future value of an investment based on constant interest rate. It can be used with either periodic constant payments or a single lump sum payment. The syntax for this function is equal to FV, then rate, NPER and PMT. 3 arguments are required and other 2 arguments PV and type are optional. So let's look at these arguments. These arguments are very important to understand because other functions such as PV, PMT, IPMT, etc., what we are going to see in the next topic, also use the same or similar arguments. So if we understand the arguments in this topic, it will be easier to understand other functions. So let's see the arguments. The first argument is rate, which is required, and this is the interest rate per period. It is important to be specific about the period here. So if the interest rate is 10% and payments are made annually, then the rate should be 10% or 0.10. But if the interest rate is 10% and payments are made monthly, then the rate should be 10% divided by 12 or 0.10 divided by 12 because the payments are being made monthly. The next argument is NPER, that is also required argument, which indicates the number of periods from now for which we want to calculate the future value. The periods for this argument should be same as those used in the rate argument. So whatever period we are using here should be used here also. Then PMT is also required argument. This is the payments made each period. If PMT is omitted, then the PV argument is required. So PV argument is required if PMT is omitted. And PMT means it is the payments made each period. For example, if we invest 100 a month for 10 years, the PMT should be 100 and the NPER, that is number of period value, should be 120, that is 12 months times 10 years. Then next argument is PV, that is optional argument. This is the present value of the investment. If PV is omitted, it is assumed to be 0 and the PMT argument is required. So if we don't give PMT, then if we don't give PV, then we have to give PMT and vice versa. So PV argument is used to determine the future value of one-time lump sum investment. We can also use this argument in addition to the PMT argument to determine the future value of an investment in which we already have money but plan to add money periodically. Then the last argument is the type argument. This is also optional. This argument takes the number 0 or 1 and indicates when the payments are due. If omitted, it is assumed to be 0. So 0 means if payments are due at the end of period, or if it is 1 means if payments are due at the beginning of the period. Then other thing we need to understand is we need to use positive numbers for inflows, that is any amounts we receive, and negative numbers for outflows, that is any amounts that we pay. We can also use FV function to calculate the future value of lump sum investment. For example, if we put 1000 in a fixed rate investment and do not make periodic contributions, we enter 1000 in the PV argument and do not enter the PMT argument. The FV function would return the future value of that lump sum investment. So now let's see some examples here. So let's take example 1 here. Find the future value of an investment if an investor puts 1000 into an investment with an annual fixed rate of return of 8%. The investor plans to contribute another 500 each month for 30 years with payments made at the end of each period. So we have a table here and we'll start putting the values. So rate of interest is 8%. Then number of period. So this NPER, here we need to be careful. Number of periods is, here it's mentioned 30 years, but it is for each month. Payment is for each month, so we'll have to put 30 times 12. So we get NP year as 360 months. Then payment. Payment is 500 for each month, so we'll put 500. But remember, 500 is going out from us, so it will be minus 500. Then just a minute, so minus 500. Then we have present value. So we already put 1000 into an investment, so we'll say minus 1000 was already put. And payment type. Now payment is made at the end of each month, so if payment is made at the end of each month, it is 0, so we get 0. Now let's enter the function here equal to FV, that is future value function. Okay. And then let's just move this. Here it's easy to understand. So FV, we have got rate is 8%, but we need to be careful because this is 8% annual interest rate. Okay, we are making payments per month, so we need to divide by 12. Okay. Then NP year is 360, which is already in months. Then PMT is minus 500, PV is minus 1000, and type is end of each month. End of each month is 0, which we already put it here, so we can close the parenthesis and press enter, and we get the future value as 756,115.45. Now let's take another example where the investor puts 1000 into an investment with annual fixed rate of 8% for 30 years, and the investor does not plan to contribute any amount in future. Okay. So here also let's directly calculate. We'll put the function equal to FV, okay, and we will have rate of 8%, and here we'll not divide by 12 because he is not putting any monthly payments. Okay. Then NPER is number of period is 30. Okay. PMT, he is not making any payments, so we can leave it blank. Then PV is minus 1000, he has already paid. Okay. And type, we can leave it blank because it's optional argument, so we'll close the parenthesis and enter. So at end of 30 years he will get 10,062.